Seen from space, the Earth is a pale blue dot. Two-thirds of its surface is covered by water, but the vast majority of that water, around 97%, is salty. Of the 3% that is fresh water, which is the kind humanity needs to drink, wash, make things, and most of all, produce food. About two-thirds is locked up in glaciers, ice caps, and permafrost. That leaves less than 1% of the planet's water easily accessible in rivers, lakes, or aquifers. In short, the salinity of oceans means useful water is scarce, while the less useful kind is abundant. So why is the sea salty? The salt in ocean mostly got there as a result of a process called weathering, which transfers mineral salts from rocks on land into the sea. Rain is not pure water, but contains small amounts of carbon dioxide absorbed from the air. This makes rainwater very slightly acidic. When this weak acid falls on land, tiny traces of minerals dissolve from rocks into the water, separating into charged particles called ions. These ions then traveled along with the water into streams, rivers, and eventually into the ocean. Many of these minerals ions are subsequently removed from the seawater by marine plants and animals, but the others remain in the ocean, and their concentration builds up over millions of years. Over 90% of the ions in seawater, accounting for about 3% of the water by weight, are sodium and chlorine ions, which are the chemicals constituents of common salt. Other processes also play a role. Underlying volcanoes and hydrothermal vents discharge mineral salts into seawater, and isolated bodies of water with insufficient drainage may become increasingly salty through evaporation, which carries water away while leaving dissolved mineral behind. The Dead Sea, which contains about 30% mineral salts by weight, is the best known example. The natural processes that makes the seas salty can be reversed by desalination technologies that turn seawater into fresh water. This involves either boiling and then recondensing water or pumping it at high pressure through reverse osmosis membranes that allow water molecules to pass but are impermeable to larger mineral ions. Both processes are energy intensive. However, though reverse osmosis has become far more energy efficient in recent years. Accordingly, desalination plants are generally found in places where water is scarce but energy is cheap, such as the Middle East. As climate change causes global drying, making some wet parts of the world wetter and dry parts drier, demanding for fresh water will intensify in coming years. Half the world's population is expected to live in water-stressed areas by 2015. Better water management policies and more water-efficient agricultural practice, such as drip irrigation, are needed. Improvements to desalination technology would help too, by allowing mankind to tap the oceans in conveniently salty water. If we could ever competitively, at a cheap rate, get fresh water from salt water, observed President John F. Kennedy in 1960, that would be a long-range interest of humanity, which would really dwarf any other scientific accomplishment.